Okay, so let us start the first numerical test in this chapter, motion. Okay, this is test 8A. These are the questions that are in your textbook that we're going to include. And after we complete this, there will be a test 8A. That is, every question will be identical to these questions. Only thing is, small changes in the numbers will be there. Okay, let's start with this first one, activity 8.7. We'll find this on textbook page 109. But write down this question because there is a slight adjustment we have made, so we can make it into the form of a numerical. Okay, so here the sound of thunder takes some time, let us say 2 seconds. We have added this. Okay, this portion we have added ourselves to make a numerical. The rest are all identical. To reach you after you see the lightning. Can you answer why this happens? So number A answer, let us write that first. Answer A. Question is saying, when you see, we have all experienced this, that when you see the lightning, right, we see it first, and then after we see only, we hear the thunder. The thunder comes late. That means the reason is because light travels faster than sound. Okay, so the light reaches our eyes faster than the sound of the thunder reaches our ear, because light travels faster than sound, or sound travels slower than light. You can say like that. Okay, so you can say here, this is because, okay, our answer, this is because, okay, to reach you after you see the lightning. So this is because sound travels, in simple form you can answer, travels slower in ear. Okay, slower in ear than light. That is why you are hearing the thunder only after you see the light. That answers your question. I hope you got it. Now let us go to the next one, B, which is the numerical. Okay, B, they calculate the distance. So here we have to find the distance. So let us write it down. What distance? Distance of the nearest point of lightning, means the position of the lightning and you, the person who is seeing the lightning. The distance between you and the lightning that you see. How far are you from the lightning? So speed of sound in ear is given. So let's write that down. Speed of sound in ear. Okay, it is given to us 346 meter per second, as you can see there, right? So speed is there, distance is there. A distance is not there, and the time is also given. The time taken for the sound of the thunder to reach us. Here, see, to reach you, say 2 seconds. So sound takes 2 seconds to reach you after you see the lightning. So it is 2 seconds here. So this is the time and this is the distance. Time, speed and distance. Now we know here, you can come and do here, since in our previous class we have learned the formula for speed. Okay, speed is equal to distance by time. We know this. That is, in other words, we want to find distance this time, so we'll keep the distance without moving, and this also don't touch speed. Now if we shift this denominator time, it will go up and multiply with speed. So this is our formula that we require now here, because we have to find the distance, right? So that will be given equal to the speed of the sound here of thunder is 346 meter into second to the power minus 1. If you bring it down, it will become second to the power plus 1, which we need not write, isn't it? So here into speed, speed into time. Sorry, this time will go up and multiply this, make the slight correction. So time taken is 2 seconds, as you can see here, right? So we can cancel this second that way, up and down, and we're left with 2 6 are 12, 2 4s are 8 plus 1 9, 2 3s are 692 meter. Therefore our answer, distance of the nearest point, distance of the nearest point of lightning, that means the distance between you and the lightning is equal to 692 meters. Okay, so which is a little bit more than half a kilometer. Half a kilometer is 500 meters. Okay, so we have done that. Now let us go to question 2 on page 107 of your textbook. So you can open your textbook and go there. 107. Do slowly, don't hurry, it's quite easy, just think and do. Okay, 107. So there, page 107 of your textbook. If you go there, so let us write that number first. Question number 2, textbook, page 107. Okay, let me read the question for us. A farmer moves along the boundary of the square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? So here the farmer has a square field, and we know that square means all the 4 sides are equal. A, and all the 4 corner angles are 90 degrees. That is the meaning of a square field. Then let us label it as A, B, C, D. Okay. And here, let A, B, C, D be the square field that is mentioned in the question of side, okay, side A equal to 10 meter, because the question tells us its side is 10 meter. Then let's go and read that. Since question is saying he moves, that means the farmer moves along the boundary, okay, along the boundary in to taking 40 seconds. Question is saying that. You can see that in the first part of the question. You can go and see if you want. Okay, so what does this mean? This means in 40 seconds he covers, okay, in 40 seconds he covers how much distance? Equal to the boundary, means one time going around the field, one time. So if you imagine he started from A and he went like this, 1 2 3 4, came to the initial point, that is called move along the boundary, means one time around, so that is 4A, which is the perimeter, A plus A, 2A, 3A, 4A. So that is equal to 4 into 10 meter, which is equal to 40 meter. So he, in 40 seconds, he covers 40 meter distance by going one time around the boundary. So let us do the mango method, okay? 4 mangoes cost equal to rupees 40. And how much is 1 mango? Rupees 40. Right side divided by left, right? You already know it's 10, right? So how we'll do the same thing. So in 1 second he covers how much? 40 right divided by left, just like we did here, right by left here, and here meter. When we bring this 40 there, we don't bring the second. The units that are on the left will stay on the left. See, it's still here. Units on the right will stay on the right. We cannot bring the unit, only the numbers can be brought, okay? So here These two cancel means we have 1 meter. So he covers 1 meter, which is equal to 1 meter. So in 1 second he covers 1 meter. But the latter part of the question says he moves, what will be his displacement at the end of 2 minutes 20 seconds. So let's just first find out how much is 2 minutes 20 seconds. Now 2 minutes 20 seconds is same as 2 into 60 second plus 20 second. See here, the conversion factor for time is hour, minute and second, and we know that the conversion factor is 60. So if you want to change this minute to second, then you're moving one place to the right, big to small, so multiply by 160. 2 minutes into 60 is 2 into 60 second. So that will be 120 plus 20, 140 seconds. So 2 minutes 20 seconds is actually 140 seconds. So let us just write here, therefore in 140 seconds he covers how much distance? Equal to, in 1 second he covers 1 meter. So in 140 seconds he'll cover this 1 meter distance covered in 1 second multiplied to this 140. And we cannot bring this second, only the number, right? So he covers 140 meter, which is the same as equal to 14 into 10 meter, because 10 means 10, right? So which we can write it as equal to 14 times, means into means times a, because a value is 10. So let his initial point be A, this capital A. So let him start from here, starting point. Let his initial point be A. So if he moves 14 times A, okay, along the boundary, okay, along the boundary. So if he moves 14 times A, starting from here, whether he go clockwise or anti-clockwise, it's up to you. You will get the same answer. So let us say he went anti-clockwise 14 times, because we get after 2 minutes 20 seconds he's going 14 times A around the boundary. So let us count: 1A, 2A, 3, 4A, 5A, 6, 7, 8, 9, 10, 11, 12, 13 and 14A here. So he'll end up at C. That means his initial point was A, final point is C, so this is the displacement, right? So if he moves 14 times along the boundary, his final position or final point will be, we know now by our common sense, we have found out, will be C, the point C. That is his displacement, that the question is asking us, his displacement equal to SC. So we need to find out this SC. Question is asking for his displacement if he moved 2 minutes 20 seconds, which is 140 seconds, along the boundary. So let us find that out. In order to do that, you look here, you can take this right triangle ADC, or you can also take ABC, up to you, okay? Because this one, either of these two involve the displacement distance AC. Why did we say AC is the displacement? Because in our previous class we learned that the shortest distance between initial point here A and final point C is the straight line. So this is the displacement, shortest distance between initial and final point. So that is hypotenuse AC square. In a right triangle, the two arms of 90 degrees are these. So the one which is not is the hypotenuse. So AC square equal to AD square plus DC square, right? So if you write your AC, we'll remove the square, then root will come. We know AD is nothing but side of the square A, so A square, DC also side. So root over 2A square. So root over 2 into A square will come out as single. That's how we remove quantities from inside a square root outside. So that is equal to here. A is 10, so it will become 10 root 2 meter. Okay, so final answer. Okay. So you write here, therefore his displacement AC here is equal to 10 root 2 meter. Okay, this can be your answer. Or some textbook, they find out the value of root 2. So in order to find that value, you have to do the square root division. Okay, square root division. So this 2 is there. Now, to do square root division, let me take an example and show you. 757681. In a decimal number like this, having decimal point, the one on the left, this part is called integral part. The one on the right of the decimals, these numbers are called decimal part. Okay, so here in the integral part, we mark the periods in the Chinese way. What do I mean by that? We write like this in English: I like chocolate. But Chinese people write from right to left, unlike us. I like chocolate. So we have to go Chinese way here. By that I mean we should not mark from here. We should mark from here. 2 digits will be under one period, means 1 bar. And if there is a single number, that should be under 1 bar. We should not mark 27 under 1 bar and 3 alone. No. We have to go Chinese like this, like this. And for the integral decimal part, like the English way, 2 under 1 bar. And suppose you have 3 here alone, then you should never keep alone in the decimal part. You put 0 and make it double. So double digits should be there under each bar or period in the decimal part. In the integral part, the last one here can be single digit also. But in the decimal part, it should not be single digit. So here we have only one integral part. So we mark here Chinese way like this, 1 period. No decimal means we have to create it by double zero. As I said, in the decimal part, single digit is not allowed. If only single digit, we have to put 0, which we are doing here. Up to 3rd place we went. It's up to you. Some people even go up to only 2nd place. Okay, so here the square root division is like this. Take the first period alone, multiply here a number to itself. Same, these two should be 1 ones are 1. Okay, now we didn't put 2 because 2 means here also we have to put 2. So 2 2s are 4, will become greater than 2. So we must choose a number here which multiplied to itself will give you a number exactly equal to this 2 or lesser than 2. 2 is not possible, so we took the lesser one, but should not be higher. Okay, after we finish, whatever number you got here, you put it here and add them up. 1 plus 1, 2. And if you see a decimal here, then you should not put down here 1 remainder. We should put it here. Then bring down the next period. Next period is not 0, okay, double 0. In normal division, we bring only 1 digit at a time, sorry. But in this square root division, under each bar, whatever double digit is there, both has to be brought down. Then put a number here and same number here. I think 4 is going, so 2 4 into 4, 96. So 2 4 and here also 4. Had you put here 5, this should also be 5. But we didn't do that because 5 will be too high. It will become 125, right? And this is only 100, so this is 4 remainder. 10 minus 6, 4. That much only. Then bring down the next period, which is double 0, not single. Under 1 bar is 1 period. So here, whatever number you used here, you put it here and add them. So 24 plus 4, 28. Now by common sense also we know if you put 2 into 2, then it will go beyond 500. 282 into 2. So this is only 400. So we should not use 2. We know now it's 1 here. So this is 281. Remember is 9, 1, here 1. Bring down the next period, which is double 0, the last one. The 3rd one, okay? So as we keep on doing like that, here whatever number you used, put it here and add 282. Then here I think 4 is going, so let's try with 2824 into 4. That means whatever 4 you put here, also 4. So 4 4s are 16, 4 2s are 8 9, 4 8s are 32, 3 in hand, 4 2s are 8 9 10 11. So 6 9 2 1 1, this is the one that is going. So 2824 into 4 is, we got this. This is never going to stop infinite, so up to third place is enough usually. So we just stop there and write the value here. This is our answer, or 10 into root 2 value is 1.414. 1.414, and here meter. In place of root 2 we have put the division value, approximate value. So when we multiply decimals to zeros, it moves right. So only 1 0, so it will move 1 right. Put in 4 and 1, so it will become 14.14 meter, approximate value of his displacement. Or some textbook accept even this one. Okay, so this is your question 2. So now these 2 done, let us go to 5. Okay, question number 5, you'll find this textbook on page number 109. So open your textbook to page 109 and let me read the question for us. Question number 5, okay. So, yes, there. During an experiment, a signal from spaceship reached the ground station in 5 minutes. So spaceship means the one that is far away in the space. Signal was sent from there and it took 5 minutes to reach Earth ground. So here, from there itself, we know the time taken for the signal to reach the Earth was 5 minutes. Okay, now as I said, I think if you read the last part, the speed is given in meter per second. So we need to change this to SI unit so it becomes second, match that. Otherwise, we cannot use this with that speed, right? So as we said here, the conversion factors for time, okay, units for time are 1 hour 60 minutes and 1 minute 60 seconds. Conversion factor is 60. Okay, so let us keep that in mind. So you're going to change minute to second, means big unit to bigger to smaller, so you have to multiply. So 5, you're shifting only one place, so multiply to 60. 1 minute 60 seconds. So that is no more minutes, second will come in. So 300 seconds, 5 6 are 30. Time is settled. Let us go back to question. What was the distance of the spaceship from the ground? So the distance is unknown. This is what we're going to get. The signal travels at the speed of light, that is. So speed of the signal. Speed of signal that was sent from the spaceship. It travels with the speed of light, 3 into 10 to the power 8 meter per second. So speed is there, time is there, we have to find distance. So let us do that. Since we know in our previous classes, I said, speed formula, we now have defined that speed is distance covered per unit time. That means distance divided by time. And we want to find distance, that is, distance we keep it as it is. Then shift time, it will go and multiply with speed on the numerator. It will go to the numerator. This will go up, right? So let us find that by doing carefully. Now here that will be equal to, speed is here 3 into 10 to the power 8 meter per second, means divided by second to the power minus 1 brought down, then become plus 1. Power will become plus 1, which we are not right? Into time here is 300 seconds. So we write here 300 seconds. That way this second and second will cancel. Then here, see, only this, okay, 3 3s are 9. Into 10 to the power 8 plus, how many 0? 2 0. Means 10, 8 to the power 10 to the power 10. Here 10 to the power 2 is there now, 2 plus 8, 10. So meter, that can be your answer. Or if suppose we can leave it like this is accepted, okay, but suppose the question asks us to change to kilometer, which is quite possible, we'll have to know to do that. So for that, as I said in our first class, conversion of distance or length, kilometer, you can write it down once more if you want. And this is absolutely important to memorize: kilometer, hectometer, decameter, meter, decimeter, centimeter, and millimeter. Now keep this in mind. The conversion factor here is 10, not 60. What do we mean by that? 1 kilometer, 10 hectometer. 1 hectometer, 10 decameter. It goes like that when you go from bigger unit to smaller unit. These are bigger units. The left side are smaller units. But if you're changing from small to big unit, 1 millimeter, 1 by 10 centimeter. 1 centimeter to 1 by 10. It goes like this. So every position shifted is 10, 1, 0, 1, 0. Here every position shifted is 60. And for both of these, if you're changing big to small unit, we multiply. That means if you're changing kilometer to meter, that is bigger to smaller unit. Small to big unit, like you're changing meter to centimeter to meter or whatever, that is, we have to divide. Okay, we have to keep this in mind. Both same for this. So if you want to change meter to kilometer, then you're moving from here to here. How many places? Don't count the first one. 1, 10, 100, 1000, 3 zeros. So 9, since you're changing small to big, you have to divide. So 9 into 10 to the power 10, same thing you write, divided by 10 to the power 3. 10, 10 to the power 2, 10 to the power 3. And meter will disappear and kilometer will come out. 10 to the power 3 cancelled, and 10 minus 3, 7 left. So that is 9 into 10 to the power 7 kilometer, your answer. Or this one, okay, so you can write here, therefore distance of spaceship from the ground, spaceship from the ground equal to, this one you can write 9 into 10 to the power 10 meter, or 9 into 10 to the power 7 kilometer if they ask in kilometer. Otherwise you can just stop it here. Okay, so one more question before we complete this portion, test 8A. So let us go and do that. Example 8.2 and textbook page 109. Okay, so these two things here, hour, minute, second, and all this for distance or length is absolutely important to memorize, because you'll keep on needing them every now and then. Okay, so let's go and read that. Okay, the odometer means that meter in front of the driver, which tells you how much distance you have traveled as you started your journey. Okay, reached 2000 kilometer at the start, means before the journey of a trip, and 2400 kilometer at the end of the trip. That means here distance traveled by the car here at the end of the journey, final reading on the odometer minus initial reading, that will give you how much distance he has traveled that day, right? So that will be 400 kilometer distance traveled given. Now for to cover this distance, it took 8 hours. So the time also given. Hour means time, right? Time is equal to 8 hours. Let's read the question carefully. Find the average speed of the car in kilometer per hour and meter per second. Okay, so here, therefore, average speed. We know the formula for speed is, okay, so we can just write here total, if you want to add that, distance covered divided by total time taken. Total time taken is equal to total distance traveled, distance divided by total time taken. That's our formula. So here total distance is, for his trip, 400 kilometer. So we write here kilometer on the numerator. Time is 8 hours. So down here, hour, right. Simple case of cancelling. 8 ones are 8, 5s are 40, 8 zeros are 0. So this is 50 kilometer per hour. But they're asking us to find in meter per second also, SI unit. So we write here, that will be equal to, continuing, 50. Now this is 50 kilometer. We need to change to meter now. Not this side, but from that side, this side to this side. So from here to here we're going. So 1, 2, 3. Big to small, so multiply. 10, 100, 1000. So 1, 2, 3. Because if movement is 1, 0, 10, 10, like that. Then the kilometer will disappear and meter will come in. Then here, we know there is no number down, means 1 is there. So 1 hour in the denominator. So that also we need to change to second. So if you want to change hour to second, you're changing big to small. How many places? 60 and 62 places. So that 1 will multiply to 60 and 60 because you're changing hour to second. 1 movement 60, 1 movement 60. Here 1 movement only 10, 10. So that is the one. So let us cancel it. 1, 2, 0. 2 3s are 6 and 2 2s are 4. 0, 2 3s are 6. Again going to 1 to 2. So this will be 125 divided by 9. 3 3s are 9 meter per second. So if you divide this, 125 divided by 9, 9 ones are 9, 3 in hand, 9 3s are 27, 8 remainder. 50 minus 7, 8. Then no more remainder, right? So that is our value. You can stop there. One way of writing is that is equal to, we write the quotient first. This is called quotient, and remainder up, and divisor, this is called divisor, down, meter per second. So therefore, we are asking calculate the average speed in kilometer per hour and meter per second. So you can write here, therefore, okay, average speed equal to 50 kilometer per hour. This one hour, if you brought it up, then hour here plus 1, we didn't write, but it will become minus 1. Textbook frequently use this, that's why I'm just writing. Or it can be 113, 8 by 9 meter, and second brought up, second to the power minus 1. These two, they're asking both kilometer per hour and meter per second. So that concludes your numerical for this test portion. You can go and take the test now.